Hello, this is Train4Print. My name is Marcus Cruz. Welcome to my treasure chest tutorial series where we in Blender 3D model for 3D printing. I have printed this treasure chest. Hope you can see it. And this is where we left off on our the first lesson, and it's very basic, and that leads us to this tutorial series. I take it from the very beginning. I explain everything, and I don't want to overwhelm you with lots of different new commands for each lesson. That may lead us to a little bit stupid or simple steps for doing things in the beginning, but as we learn more and more, I will explain how you can make your workflow more efficient. This is the 3D viewport. It's the most important view in Blender. We can see our objects in 3D. We have the N panel here. We toggle it with the N key. I can see the item, I have tools, view, and so on. Under here we have a little window with the timeline. If we want to animate things, we will use the timeline. We will go into that later. Here we have the outliner, and it will list all the objects we have in our scene. We can select things by clicking on them, and we see here that the cube is not a cube at all anymore, but cube is the name of the object, and because it started as a cube, its name is cube. So let's rename it by double clicking it. Chest. It's very good that we can organize our work. This here is the properties window. It has many tabs, so I would say this is the second most important window. Here in the 3D viewport we can, as you might remember, pan around the object like this, holding down the middle mouse button. If we hold shift, we can pan around like this. You can also left click here to do the same thing. But if we want to view the scene from a specific angle, we can use the numpad keyboard. Numpad 1 is the front view. Numpad 7 is the top view. Numpad 3 is the side view, and it's from the right. I can always rotate the scene around this like usual, but I can also use these, and it's very handy to have these views. If I hold down Control, I see it from the opposite angle, so Control 1 is from the back, Control 7 is from the bottom, and Control 3 is from the left. When we go into these modes, it actually toggles the view to an orthographic view, but as soon as I start to rotate the scene, you see there is a little flip and it turns into perspective mode. Pressing numpad 5, you can actually toggle between perspective and orthographic. If we press numpad delete, we focus on the selected object. Very handy. If we get lost, we can also press 4 and 6 to rotate the view around the object. We can press 8 and 2 to rotate up and down. That's for numerical keyboard navigation in the 3D viewport. You have to have the mouse cursor in the 3D viewport for this to work. If I go into the outliner with the mouse, I can't navigate anymore. I have to be in the 3D viewport. One thing I must do with this object before we start to edit it is applying the scale. See here, I have selected this object and in the item tab I see here that the scale isn't 1, it's something else, and then I press Ctrl A and scale. Now it's 1. That's very important because when I use numeric input, I want this to be Blender units. If we always scale in edit mode, we will never change this. So as a rule of thumb, either always apply your scale with Ctrl A, scale, or do your scaling in edit mode. Time to go into edit mode and start working with this. Today we're going to do the metal reinforcements that are along all these edges, and there we will use the inset tool. The inset tool can be done with the I key, and we just drag our mouse and we can right click to cancel it, we can left click to confirm it. Let's undo that. But we want to use numeric input for this, and I want these to be 1.5 millimeter. Yeah, so 1.5. I can select multiple. If I hold down shift, I can add to my selection, and then I inset all these at the same time. 1.5. If when you do that it looks like this, that means you're insetting all the faces at the same time. But if I press I again here, I toggle it to individual faces, and I can actually toggle between these two at any time. So I want it to be individual. There is also a checkbox for it here after the command finishes. So I want it to be 1.5 all at the same time. Yeah, select these two, 1.5. This looks a bit weird. What's happening? This is self-intersection, and it's bad. The geometry is weird, and one sign of this is this flickering when we rotate the view. But if we add this to a slicer, the results can be unpredictable. Let's fix that. So I go into side view, I scale it down, then I will use the merge tool. I will select this last, and then I press M for the merge tool, and at last. So I glue everything into that last. Now it looks fine. No more flickering, no self-intersection. So let's do the same thing here. Let's scale it down first. I press Ctrl 3 to view it from the left side. You can actually write on the line there. I hold down Shift and click. Merge at last. Now where there previously were a bunch of vertices, there's only one now. Good. So I go into front view and face selection mode, and I drag a box around this. But since we are in solid view, the ones hidden or facing away is not selected. So if I go into front view and wireframe mode, I can drag my box around all these. Now I have selected all of them because the back facing were visible because of wireframe mode. You see, I toggle very quickly between solid and wireframe mode. I hold down Z and I flick the mouse left to right, left for wireframe mode, hold down Z, flick, let go. Very good. So now I want to inset this 1.5. What happened here? I see here that I have this individual checked. I don't want that. So now we have this and we get self-intersection again. And if we view it from the side, we see that this goes straight up. That's no good. So we actually want it along this face. So I would say select all of these and merge it to that one. Merge last. Merge at last. It's a bit tedious to go around and do everything 4 times like this, don't you think? There is actually a much smarter way to do that, but I think we will go into that for lesson 3. Right, so we have these self-intersections. We see here that looks a little bit strange, and that's because of we see here that it's a little bit strange geometry here. It's nothing incorrect. I think that when we print this won't be visible. The computer view enhances it. So let's do the actual insetting here, or not insetting. We want to extrude inwards 0.5 millimeter. That looks good, but this face here, if we were to print this on an FDM printer, this would be a long bridge. Not that long, but most printers would have no problem with this. But if we were to scale up this object, it might not look that good. So I will take this edge, GZ minus 0.3. That's good. Let's do all the others. And if we, this is strange, because they're all going in the same direction. So what we want to do here is another tool that's called shrink fatten. So I right click, the extrusion is done but with a 0 distance. So we have a bunch of edges here around. We have duplicate geometry, and now if I press Alt S, we can shrink these into the surface or fatten them outside. We want to shrink them by 0.5 minus. We want to move them out by minus 0.5. That becomes inwards. If we go into the top view in wireframe mode, you see that this is what has happened. We can view this from the top. Alt S, minus 0.5, enter. Good. And we can take all these, move them down, G, Z, minus 0.3. Good. All overhangs, good. We can also take this one, and remember, we extrude, but we right click, so the extrusion is done, but with a 0 distance. And then we use Alt S to shrink fatten, minus 0.5. Good. But what do we do with this overhang? If we take just this and move it down, it will be, we want actually to, we want to fix this somehow. So this is one way of doing it. There are many ways of fixing it, but we scale it some distance along the Z axis. So S for scale, Z along the Z axis, like this. And then we move it down again along the Z axis. Now we've mitigated that overhang here. Perfect. So time for the last, and as the last time, we go into front view. We drag a little box around these in wireframe mode, so we catch both the front and back. We extrude. Look here, if we extrude, everything goes up because it takes the mean normal of all the faces. Right click to cancel it, so we extrude with a 0 distance and then shrink fatten. This is quite nice. So it moves along the normal, and we can minus 0.5. This looks much more like a chest now. Not bad. Yeah, take a moment and inspect your chest. That's not a bad chest right now. It's time to export this. We have it selected. You can see here in the outliner that it's only the chest that is selected. File, export, STL. And we name it Treasure Chest Part 2. And we check this selection only. Now we can slice it and print it. Lastly, I want to show you the 3D print toolbox. So this is an add-on in Blender. It's shipped with Blender, but it's not enabled by default. And the way to enable it is you go into the Edit menu, Preferences, and then you select Add-ons and you search 3D, and then you will find it here. Make sure it's checked. Go here, Save Preferences, and close. I will have this here, and we can do solid. That checks that the mesh is manifold. In other words, it has no holes or some kind of weird geometry. Let me show you an example. We create an icosphere here. Numpad delete to focus on it. We go into edit mode, face selection mode, and we delete. Now this isn't watertight anymore. You can think of it as if we fill this object with water, will it leak anywhere? It's not the only definition of manifold, but it's one. And if it will leak, it has a hole. 3D printers can't know for sure what's on the inside and on the outside. In this case, it's pretty clear that we can just fill this hole. But let's inspect it with the 3D print add-on. It actually noticed that it has 3 non-manifold edges. Yeah, it's these 3. This is the hole, and we can open this, clean up, and click Make Manifold. We see that it added 1 face, and now it's whole again. Intersection is another. If we do it like this, see if we can, yeah, this will probably result in an intersection. Yeah, so this is very bad geometry. What exactly is on the inside and what exactly is on the outside? But if we take this, scale it down again, the intersections are gone. Very good. I delete this example object, and we can inspect our chest. So it has no non-manifold edges, it's watertight, and it has also no intersections. Right. Thank you for following me all the way here, and have a good day. See you next week. Bye.